Hi everybody, Mrs. Bowen here, and we're going to continue looking at Standard 21 and 22, Area and Parts of Figures, Day 2. But in this video, we're going to look at a trapezoid. So to talk about parts of a trapezoid, we're used to talking about a base and a height. And if we reference our trapezoid, we're still going to have a height. So that hasn't changed. So we will still reference our height. And so here would be our height, it's perpendicular. But when we go to talk about bases, we're actually going to have two bases. We have a top and a bottom base. So my height is still perpendicular to my bases, but I could say that I have base 1 and I also have a base 2. And the reason I'm differentiating here is because you'll notice they are not the same. With parallelograms, we said our two bases were the same length. And here, if let's say we have base 1 and base 2, they are different lengths. So we could say this is base 1 and this is base 2. And here's our height. Base 1 and base 2 are different. And so our base 1 is perpendicular to our height. Our base 2 is also perpendicular to our height. Our two bases, and this I guess goes back to some of the properties that we learned about trapezoids, our two bases must be parallel. And our bases and our height must be perpendicular, which we talked about. They have to meet at a 90-degree right angle. So we still have a height and it's perpendicular to our two bases, but we have two separate bases. We have base 1 and base 2. When we try to think about area of a trapezoid, it's a little bit tricky. If this were, say, a rectangle, we would just do base times height. Right? Base times height. However, we can't quite do that. We can't take half of it. This isn't a triangle that's taking up half of the rectangle. We have a height and we actually have two different bases. So it's almost like we want to average the two bases and multiply that by our height. So almost like if we could have a different baseline, like here halfway in the middle, an average, and multiply that by our height. So the way we can represent that is we can do 1/2 times our two bases, base 1 plus base 2. So notice here I am using B1 for my base 1 and B2 for my base 2, and it doesn't matter which one you identify as base 1 and base 2. Just know that they're two separate lengths. By doing half times my two bases here, this is finding the average, right? I'm adding my two bases and I'm dividing it by 2, or I'm taking half of it. And then that gives us a good average for our bases, which we can then multiply by our height. So the last part to our formula here will be times our height. And our height again is perpendicular to those two bases. There's another way that I sometimes see the formula written. I'm not going to use it this way, but sometimes you do base 1 plus base 2 divided by 2, and then whatever you get, you times your height. But I'm going to use this formula. I'm going to say I'm going to take half of my two bases added together and then multiply by my height. Let's look at what this looks like when we actually have some measurements on our trapezoid here. So if we look at example E, I have a figure, and right away I'm actually going to write my formula. Area equals 1/2 base 1 plus base 2 times my height, just so I have it and I can reference my formula. And now I need to go identify the different parts of my figure. So my height here, I see that it is perpendicular to the two bases, so my height is the 8 meters. And I have two different bases. Again, it doesn't matter which base I say is base 1 and which I say is base 2, but I have one base here that's 3.5 and another base here that's 7.9 that I can plug in for base 2. So I've identified two bases, they're parallel to each other, and they're perpendicular to my height here. And so these are the different measurements I need to plug in. So I'll have area equals 1/2 times my base 1 is 3.5 plus my base 2 is 7.9 times my height of 8. And the only thing I need to do here is be careful with these parentheses. So this means if I want to type this whole piece into my calculator, I may, but I have to use parentheses. So I could type 1/2, or I could do 0.5 times parentheses 3.5 plus 7.9, close my parentheses, and then put an 8, and my calculator will know how to do that order of operations. Or you can break this up, and I can do 3.5 plus 7.9 in my calculator. I could take half of 8, which is 4. So you can simplify it and do it piece by piece. You can use your order of operations, or if you type this whole piece in your calculator, that's fine, but you have to use parentheses. So when I complete this using order of operations, here I get 45.6 square meters for my area for my trapezoid. Let's look at one more. So example F, the figure is actually a little bit easier to look at. I'll start by writing my formula. Area equals 1/2 times base 1 plus base 2 times my height. And let's go identify the different parts of our figure. So I see my height here perpendicular to my two bases. So the height that I'm going to be plugging in is 4.3. I have two different bases, and again, it doesn't matter which I say is base 1 and which I say is base 2. So let's say this is our base 1. And that makes my other base that's parallel to it here, my base 2, the 3.5. So then here are the different values that I need to plug in. So I'll have area equals 1/2 times, and I add my two bases. So I have 8.9 plus 3.5 times my height, which we said is 4.3. And then again, you have to be very careful when doing this. You could say, these are really three things being multiplied, right? I could do half of 4.3, and then I could also simplify in here and do 8.9 plus 3.5, and then I could multiply those. You could also type this whole piece in your calculator, and I could do 1/2 parentheses 8.9 plus 3.5, close my parentheses, times 4.3, and I will get 26.66 square kilometers. All right, so at this time, you have a few U-tries to do. You have U-tries 5 and 6, which you're going to use your area of a trapezoid for. And you also have U-try 7. And in U-try 7, you need to use your knowledge from the last few videos. We've learned area of a parallelogram, trapezoid, and we've talked about area of a triangle. So you're going to have to use this figure, use your tick marks, use some of your different knowledge here in order to try to find the areas of these different figures. So at this time, go ahead and pause the video. On U-try 5, my height was 3 and my two different bases were 2.4 and 8.2. So plugging that into my formula, I got 15.9 square yards. On U-try 6, my height was 9.1 and my two bases were 10 and 4.4. So plugging that into my formula, I got 65.52 square feet. For number 7, let's break it up, and I tried to use some color here because this figure was pretty complicated. So first I was asked to find triangle WVZ, and so I highlighted that in purple, WVZ. And in order to find area of a triangle, our formula is 1/2 base times height, and we learned that in our notes. So I need to know the right angle, and here's my triangle. So my base here is 14, and my height is actually outside of this triangle. It's over here, as if we were to extend the lines in order to use this height right here. The height is 15. So I'm doing 1/2 times base times height, and I get 105 square units. For the parallelogram, I highlighted it here in orange, and our area for a parallelogram is base times height, and I actually had both of those. My base here is 13, and my height, which is perpendicular, is 15. So I get 109.95 square units. For the trapezoid, that's the whole overall figure. So for that formula, I was doing 1/2. I needed to add my 2 bases times my height. My height here, the perpendicular height, is still 15, but I needed to discover my 2 bases. So my base 1 would be up here, 13. And my base 2 is all the way along the bottom. So for my base 2, I needed to know the total base. So from here to here was 14. And the top of my parallelogram was 13, then the bottom of my parallelogram was 13. So you could have just labeled this, right? 1 tick mark and 1 tick mark. I could have labeled this 13. 14 plus 13 gives me 27. But what I did here, just because it will help me here in a moment with the next part of my problem, if this little piece was 5, then this piece here was 8. Because I could do 13 minus 5 to get 8. So I just labeled it this way instead of labeling it as 13 right there. And so my 2 bases were 13 and 27. So I'm doing 1/2 times my 2 bases, base 1 plus base 2. So 13 plus 27 times my height. Make sure you type it in your calculator just like this. And I get 300 square units. And then the very last piece was the right triangle with hypotenuse XY. It has the side XY. And here's the side XY. So I labeled it as the hypotenuse. Here's the right triangle we're talking about. And in a triangle, we do 1/2 base times height. So my height is 15. And my base here, I mentioned that if the whole way across this parallelogram is 13, and we do 13 minus 5, then we would get 8. So my base for this right triangle right here is 8. So I'm doing 1/2 times 8 times 15, and I get 60 square units.